These Hampshire maths teachers have come together to discuss ways of motivating GCSE pupils, something that's been identified as a national problem.
This one has got loads of things on it with lots of very pretty pink.
They're sharing some new projects they've been trying out in their individual schools.
But it's interesting to look at the risks they are prepared to take, which is to follow an absolute...
One of the session organisers is Alison Clogg-Wilson from the Maths Centre at University College, Chichester.
Were they looking at what each other were doing? Because often these lessons, it goes two ways. They can be so engrossed in what they're doing they don't, or if they're at a bit of a loss, they sort of have a wander around and...
Thought, no, we're not going to do something that's wrong, so they turned over and they stuck to a rigid formula.
Yeah. Could you describe some of the things...
The other is Maths Inspector and Advisor for Hampshire, Ron Taylor.
A lack of knowledge, as you described.
We really went right back to basics, back to substituting in numbers, what a coordinate is, what is an x, which is the x value, which is the y.
What age or level were the pupils?
It's a mixed ability class, so the grades go right from D to B.
What the task was, they'd done 2 or 3 lessons on introduction to trigonometry. So what they were able to do was identify the trig ratio that they could use. They were able to find angles.
So they had a table of values, a graph, and the 2 forms of the function.
They had something like that where they put the data in themselves, but at the same time I did that on a spreadsheet, so if anyone was away...
The group has drawn up a list of desirable working habits they want to encourage in their students.
I mean, I think it'd be useful for me anyway, for us to reflect upon which of the work habits now you were trying to promote and the progress you think that your pupils have made with those.
What I included was going through a systematic approach.
These include pupils taking ownership of their learning, being motivated and engaged by the activities, and developing critical thinking. So why did these teachers volunteer to come to these sessions in the first place?
They're here because something's not working. So that in itself gets them to examine their own practice. Now, if what they've done in the past is not working, and that's because they've had maybe a narrowly focused diet of textbook work, as quite a number of the project teachers have mentioned, then yes, they're going to try something else, because if something's not working, they're going to change.
What we haven't got here is a course that is telling teachers how to teach maths 14 to 19 or 14 to 16.
The introduction of the strategy at Key Stage 1 and 2, and then at Key Stage 3, focused teachers' mind and gave them time to address the Key Stage 3 issue. Since then, Key Stage 4 hasn't actually sort of built upon what was happening at Key Stage 3.
And undoubtedly teachers are under pressure with league tables and pressure to meet targets.
And linked to that, of course, is the range of textbooks that tend to address the examination. So teachers at Key Stage 4 are driven, as Alison said earlier on, by the nature of the test and the content of the test, and don't feel they can be freed up in the way they have done at Key Stage 3.
The outcomes is a large section of pupils who are fairly switched off by the mathematics that they're doing at Key Stage 4. That doesn't necessarily always mean it's poor behaviour, but it certainly is a lack of interest and a lack of enthusiasm, which is hardly surprising if you look at the diet that many pupils experience.
The line of best fit through the mean. So we worked out what the
Head of Maths Andrea Willis describes the project she's tried out with her Year 10s at their school in Fareham.
My intention was to work with my Year 10s because I'm starting statistics with them at GCSE, and I wanted to introduce a statistics module in a bit more interesting way rather than I did last time I did it, where literally we chucked the textbooks out and that's what we did for the next 3 months. And what we're going to do, objective, to be able to use statistical measures and forms to investigate how many manufacturers decide on the sizes of collars and cuffs. And the second objective for today is obviously to use a graphical calculator to produce a scatter graph or diagram. Has anyone got any idea what the ratio might actually be, or what connection, what correlation there might be between the neck and the collar cuff size?
Like you measure around your neck and it's 2 if you want it.
Yeah, that's pretty good. Pretty good. Hannah said, 2 round your wrist is going to be your collar size. And we are therefore going to then prove or disprove it by doing certain calculations. What do you think the first thing we actually need to do is? Dom.
To measure the
Yeah. Cover your wrist, yep. And then measure
the neck.
The neck. So what I want you to do, just go around your neck, obviously not tight, and just put your finger, open it, and then measure the distance. And then do the same for your wrist size, and just write it in your exercise book.
The first part of the lesson had the students collecting their own data, the circumference of their necks and wrists, rather than using lists of data from a textbook.
At Key Stage 3 we do some really interesting stuff, we're always doing practical stuff, really nice activities, and at Key Stage 4 it tends to be so textbook based that I wanted to try to get away from that. Right, can I have your wrist size first?
18 centimetres.
Right, 18, and neck?
37 for my neck.
Right, just keep going round.
Andrea then collected the class's measurements so everyone could use them.
17.5, next one.
15 and 30.5.
15 and 30.5. Knowing that they were starting their GCSE statistics this term, I just wanted a more practical approach to doing it rather than just giving them the data and using the textbook to work through. To try to make it more interesting, more real to them, and hence motivational.
16 and 34.
16, 34. Yep.
18 and 32.
16.5 and 37.
Did you pin yourself down to which of the working habits you were particularly focusing on?
I wanted pupils' engagement, interest, and them thinking about things themselves, so the sort of questioning side of it. It's their own data, they've collected it, and it actually has relevance, so they're more engaged, and I think as a result it has therefore been more motivational. So what we're going to do now is actually use the graphic calculator. So you need to turn the calculator on, and we're going to put this data into a list. We're going with the wrist size first. So what you have to do in order to put the data into the list is just write like 18, and it comes up list 1, number 1 is 18. Use the down arrow key and you should see 18's just appeared. The next one was 17, so put that in. And you're just going to continue down until you've finished all those. And then repeat the process with list 2.
While the students entered the data into their own calculators, Andrea did the same on hers, connected to the overhead projector so the class could follow the procedure.
If you can then just have a look at the bit where it says enter in a formula and actually have a go and see if you can actually do that on your own. Yep.
Then they calculated the relationship between the two lists of measurements.
And we're actually doing list 2 divided by second list 1. Okay, so what we've done there, we've put the actual formula in, list 2 divided by list 1, to actually get what the actual ratio was. And looking at this, there are an awful lot there that's saying it's 2, 1.8, 1.9. So can you get your calculator and go?
Next, to create the scatter graph itself.
Your X list is going to be your wrist size, and your Y list is going to be your neck size. Okay, and then what we should get is a scatter graph. Now, what is the purpose of a scatter graph? Purpose of a scatter graph, Dom?
Is it to compare data and
Girls, thank you.
try and find any anomalies that there might be?
You could certainly look for an anomaly, but another thing, I think the first thing you're looking at is actually to look if there is a connection between the data. We are going to press graph. Looking at this scatter graph, is there a correlation between wrist and neck size?
As one size increases, so does the other one. They both go up.
Excellent. It's got a positive correlation there. As wrist size increases, so does neck size. And we've also said, basically, that 2 of the wrist sizes actually makes your collar size.
Can I ask, do you think using the graphical calculators actually helps you to reach some of those good working habits?
Having that sort of handheld technology they see that as being we've got something and it's more interesting than just sitting there and doing a new exercise book. So it's definitely more motivational, and therefore like they get engaged in the activity more. They want to think about what's going on more because it seems more interesting for them.
In later lessons, the class went on to create lines of best fit for this data and to discuss what they meant. They also considered what effect the accuracy of their initial measurements would have on their results.
And it was a really nice lesson. The kids seemed to sort of really enjoy it. And I mean, I've got some comments that I understand this lesson well today. I like it more. I like more interactive work because I like finding things out for myself or in a group. I think it helps me understand the work more.
It was better doing it as a class and getting the data ourselves because we're actually doing it, so it's easier to learn.
You got a lot more out of it working as a class, like going through it step by step individually and working out it all together. It helped from each other, and the sheet helped a lot.
It was easier doing it as a class because we didn't have to do it all ourselves. Everyone else was helping.
Because we don't usually do much practical in maths, and when we do come across one, it's actually quite fun.
For me, it was like, well, let's see how it goes with their data, and if it works, I'm going to take this on and I'm going to continue to use it to do a mini project. If it doesn't work, if it's sort of like ends up being a bit of a flop, then I'll move on and find a different way of actually doing it.
Which of those would you say you've most addressed?
I think sort of the ownership one. They've got ownership of what they're actually doing, and they can comment on their own mathematical progress. So I think out of everything that I was doing, I think that was probably the most important one there. Right. Range of visual, mental models to link ideas and make connections when solving problems. Well, we had the graphic calculators, we had them drawing it for themselves, so we definitely had a sort of different range of ideas to. And discussion with a partner, and we didn't do it as a partner, we did it as a group. But they actually, because they were all working together and they felt that no one was getting left behind and they could all discuss it for themselves, that it was...
Right, so learn from each other then,
yeah.
that bit, was it?
Yeah.
Okay.
Pupils in maths in this school perceive they can do it. It's perceived as a subject where they don't fail and they can do well, whatever level ability they are, they actually do well. And I think whether they're the least stable pupil in the school or the most stable, I think we give them encouragement, and I don't think anyone, even in your lower set, thinks they're not very good at maths.
You promoted that kind of approach and attitude?
Yeah, I think we do. I think it doesn't matter if you're wrong, and we don't perceive them to be thick or stupid or whatever because they're wrong. You just encourage them and sort of develop the ideas from what they're thinking. We are still teaching the curriculum, but we're doing it...
A final word from Hampshire Maths advisor Ron Taylor.
What we're trying to do is explore their beliefs about what they consider to be a good education mathematically, ways of addressing that without actually sort of, if you like, threatening the results as well. So we are tackling their beliefs. We're also, if you like, trying to give them confidence to tackle a curriculum in a way which is going to give the children a much broader range of skills and mathematical process, if you like, which doesn't actually deny them the success at GCSE, but actually conversely improves their results at GCSE.